Hello, boys and girls. Today we are doing a quick review on solving equations by addition and subtraction. So before we get too far, let's make this look like an appropriate addition sign and remind ourselves what an equation is. An equation is a number sentence with an equal sign. Equal sign, equation. That's your hint that you're on the right track. So we're solving equations, number sentences with equal signs, by using addition and subtraction. The goal in solving any equation is to get the variable on one side all by itself. We want the left side of the equal sign to be equal to the right side of the equal sign. And we're trying to figure out what value for x makes that true. Now I know this is a review for most of you. My 5th grade daughter's homework looks a lot like this. So you've seen it before in 5th grade, you've seen it in 6th grade. So this is something that you have practiced, and we're going to go a little bit fast today so that we're not wasting anyone's time. So example 1, 5 plus x equals negative 23. We're going to try and figure out what value for x makes that true. And example 2, we're going to change just a little bit. We're going to cross it out completely. We're going to get rid of those fractions, and we're going to make a new example. And your new example is going to be 5 is equal to x minus 11. We're not working with fractions yet. That's coming up here in a couple of weeks. So example 1, we like the way it's written right now. We've got our x on the left-hand side. Example 2, I don't like when my x is on the right-hand side. I like it better when it's on the left. So we're going to move everything to the other side. And the way I'm going to do that, I'm going to move my equal sign to the right. And everything that was in front of the equal sign, I'm going to move to the other side over here. And we're just going to scribble that out. So x minus 11 is equal to 5. We haven't changed the equation, we just wrote it in a different order, and it makes it a little bit easier to solve. So step 1 in solving equations. We're going to draw railroad tracks. We're going to draw railroad tracks on each side of the equal sign. Now if you went to school here last year, you've seen this before. If not, here's what we mean. We have 5 plus x equals negative 23, and I'm going to put a line down each side of my equal sign. And I'm going to do it over here on example 2 as well. Now we're going to circle the variable. We're going to circle the variable or the letter that's in the equation and anything attached to it. We're going to circle the variable and anything attached to it. And then there's a little hint at the end not to forget the sign. We don't want to forget the sign that's in front of the variable. And this is going to come into play a little bit more in a few more days, but we want to get in the habit of doing it now. So in my first example, I'm going to circle my x, and I'm also going to circle the plus in front of it to remind me that that's a positive x. And in my second example, I'm going to circle my x. It doesn't have a sign in front of it, so we're assuming there's a plus sign there. All right, now step 3, we want to get the variable by itself. We want to move everything else away from the variable so that it's the only thing on that side. And we do that by using inverse or opposite operations. We use inverse operations. So remember, whatever you do to one side, you must do to the other. So whatever we do to one side of our equation, we must do it to the other side as well. So when we look at example 1, we have 5 plus x equals negative 23. Right now, this 5 doesn't have anything in front of it, and we're going to assume that there's a plus sign there, that it's a positive 5. And we want to use inverse operations to get that x by itself. So the inverse of adding 5 is subtracting 5. And remember, if we do it to the left, we also have to do it to the right. So I subtract 5 from both sides, and when I subtract 5 from this side, a plus 5 and a minus 5 cancel each other out, and all that I'm left with is my x. And I rewrite my equal sign, and on my right side I have negative 23 minus 5. So I'm going to get out my calculator and put negative 23 minus 5, and that's going to equal negative 28. That's going to equal negative 28. And now we want to do the same thing on example 2. Right now I have x minus 11, and the inverse of minusing 11 is adding 11. And if I do it to the left-hand side, I also have to do it to the right-hand side. So I'm going to add 11 to the right-hand side. So on this side, those cancel each other out, and all I'm left with is an x, and I rewrite my equal sign. And 5 plus 11, I'm not going to use my calculator because I can do that in my head. 5 plus 11 is 16. So we think that x is 16. If we did the math correctly, x should be 16. So down here on steps 4 and 5, let's fill those in. Step 4 we've kind of done already. We are solving. We're going to solve for the variable, and we're going to leave the equal sign. So we've done that already. We solved for the variable, meaning we got x by itself, and we left the equal sign the way it is. Step 5 is to check your solution. Step 5 is checking your solution, and this is the part most of you like to skip. We think we know that x is negative 28, but I want to make sure that x is actually negative 28. So in my calculator, I'm going to do this problem, but instead of x, I'm going to sub in negative 28. So the first thing I have is a 5, and I subtract 28, and I get negative 23, which is what I wanted. Now I'm going to check this example. I think that x is 16, so instead of x, I'm going to put 16 in its place, and I'm going to subtract 11. And when I do that, I get 5, which is what I wanted. So I know that my answers are correct. Before I submit my test, before I turn in my quiz or my homework, I already know that I have the right answer because I plugged it in and made sure that it works. All right, now we're going to do a couple examples together, a couple more examples together, and then I'm going to give you some time to try these on your own and see what you can do without me walking you through it. So our first example is g minus 16 equals negative 52. We draw our railroad tracks, and we circle our variable, and there's no sign in front of it, so we're assuming it's a positive sign. And now I use my inverse operations. Right now I'm doing minus 16, and the inverse of minusing 16 is to plus 16. So I'm going to add 16 to both sides. And on this side, that leaves me with g is equal to negative 52 plus 16. Gives me negative 36. So I think that g is negative 36. But I want to make sure, so I'm going to put it back in where my g is and see if I get the answer that I want. So instead of g, I get negative 36 minus 16, and I want it to equal negative 52. And it does, so I did the math correctly. All right, now let's move to example number 2 here. Negative 12 plus x equals 100. The first thing I'm going to do is draw my railroad tracks. I'm going to circle my x and everything attached to it. And now I'm going to use my inverse operations. On this side, I have a negative 12, which is the same thing as minus 12, and the opposite of minusing 12 is to add 12. So I'm going to add 12 to this side as well. They cancel out over here. I'm left with x equals 100 plus 12. I'm good at math, so I know how to do that without my calculator. My answer is 112. I think that x is 112, but I want to make sure, so I'm going to plug that back into my calculator. Negative 12 from right here, and then I need a plus, and I think x is 112, so I plug that in, and I get 100, which is what I wanted. So again, I did the math correct. All right, let's look at number 3. Again, I crossed out this example. It's ugly, it's got fractions and rational numbers. We're not working with those yet. We're working with integers. So I rewrote a different problem here for you. It's 30 is equal to y plus 17. Now I told you before I don't like my y's on the right hand side, so I'm going to move them by moving my equal sign first, and I'm going to take this 30 and move it over to the other side. So y plus 17 is equal to 30. I draw my railroad tracks. I circle my y, and right now we're adding 17, and to undo adding 17 I need to minus 17 from both sides, which makes this side go away. I'm left with y is equal to 30 minus 17. I'm going to put that in my calculator to make sure that I do the math correct. 30 minus 17 is 13. So I think that y is equal to 13, but I want to double check. I want to make sure that I'm correct. So I'm going to plug in, instead of my y, I'm going to put a 13, and I need to add 17. 13 plus 17, and if it's correct, it should equal 30, which it does, which means I've done the math correct. I know I'm going to get the problem correct on my test because I already found the answer. So what I'd like you to do now is, you've got a few more problems here on the other side. I want you to work through those on your own. I crossed out number 3, again with those rational numbers with the fractions, and I wrote a different problem that I want you to do. Do these 3 problems on your own. When you're done with them and you've checked your answers and you know you have them correct, bring it up to me at the kidney table. I'm going to look it over real quick, make sure that you have it done correctly, and I'll give you the assignment to work on for the rest of the day.